Hi, good afternoon. My name is Velaga, and before I get started, I do actually want to thank Albert and Deepak for hosting this meeting together. Quite an insightful day. And when Albert reached out to me, he said, hey, Ram, could you show up for this presentation and talk about disaggregation? Kind of occurred to me that disaggregation is something that people have talked for a very long time. And then the real question is, where are we in that process of disaggregation? And this morning, I came over here, I sat next to my old friend, Sujal, who used to be at Broadcom. And Sujal looked at me and he said, what are you here for? What are you talking about? I said, disaggregation. And he said, dude, you've been saying that for 6 years. You still are using the same story. I said, look, I'm a part of the new Broadcom. We can't spin up new stories every day. We just keep talking about the same story till we've actually achieved the goals of what we said we want to talk about. So let me ask you something. What do you think is common between Bitcoin or blockchain and disaggregation? Anybody want to take a guess? Hashing? Great, OK. I actually would like to understand how. Anybody else? Distributed, OK. Sorry, what was that? Virtual. OK. OK. All right, great. Actually, I can tell there's a lot of technical crowd here and not much of an economist, right? So all of these go through a hype cycle, OK? Whether it is a blockchain, a Bitcoin, or some other new paradigm of the day, or disaggregation, they go through a hype cycle. And this is exactly what Sujal mentioned to me. He said, hey, we've been talking about this for 7 years. Where are we with disaggregation? And if you look at disaggregation, what actually caused the initial notion of a disaggregation to start to stick in the marketplace? And this was actually, I would give credit to James Hamilton from AWS. He wrote a paper a long time ago that showed very large OEM switches. And he basically said, networks are in my way. And what he meant by that is the scale at which the mega-scale data centers were growing in terms of their compute needs and storage needs, the switches which were then available through OEMs were just not able to keep up. They were not able to keep up because the underlying chips that they were using to build them weren't necessarily being built for these mega-scale data centers. They were kind of being built for the general purpose use cases, everything from an enterprise to a service provider to some of the even the small and medium business kind of environments, and they didn't have the scale. So James said, look, I just got to go buy silicon as it's available, the best silicon that's out there. I have to go find a way to build this hardware, and then I have to just go find software to start building this. So that's where this whole notion of disaggregation started. And this was almost about 10 years ago now, right? Then as you would see in any hype cycle, there is going to be a lot of people and large ecosystems being formed that says, OK, great. You know what? We're all going to jump onto this bandwagon of disaggregation. There was third-party noses, and there was ways to basically look at abstraction layers, and and then even people like Facebook started to actually make a significant contribution to moving this disaggregation forward with things like contributions to OCP. So they were able to standardize the hardware and get more and more of the ODMs to build towards common hardware. And then you look at it and say, obviously, over a period of time, where we are is when you start to look at this, the OEMs looked at this and said, OK, this is starting to be real. We have to start playing in this space, and we have to respond, because if we don't control the narrative here, then we're going to end up having, having no seat at the table, so to say. So they responded by essentially dropping their prices. They said, hey, we will give you, based on merchant silicon, you wanted merchant silicon that has the bandwidth, so we'll give you based on merchant silicon, boxes which probably are very price competitive to ODM-based boxes, right? And then they said, we will also sell you software separately from the boxes. If you want, you can just buy our software. You can put it onto any of the hardware that you want to buy. And basically, what that started to create was it starts to fracture your ecosystem of hardware. And then at the same time, you also see no new ODMs. There was the first 3 or 4 ODMs which were playing here. Then slowly another 2 or 3 start to come in. So there's more and more of ODMs coming into this place. And then obviously, last but not the least, none of these switches can actually be deployed without optics, right? You can have 10 gig and 25 gig and 50 and 100 gig, but if the optics are not there, you can't deploy them. And the rate of availability of optics has actually slowed down the adoption of these disaggregated systems. So where are we today? I would say, essentially today, where disaggregation has been most successful or adopted is largely the mega-scale data centers. Because one, the scale at which they deploy, the clear economics of disaggregation makes sense. And two, the pace at which they'd like to move forward is not necessarily the pace at which vertically integrated systems might be available for them, right? But then you say, is this a solid ecosystem? And can this actually maintain the rate of innovation that we would need to have going forward, right? So how do we actually get this to continue to grow rather than plateauing out at this state? So to answer that question, the first thing you want to think about is, what is a switch? And what are all the different elements that go into it? And what are the development cycles for all of these different elements that go into this, right? First, there is an silicon in there, right? Whether it is a 3 terabit switch or a 6 terabit switch or a 12 terabit switch, you need a silicon. And generally, these are today at a development cycle that's roughly about every 18 months. You should be able to see from the ecosystem doubling of bandwidth every about 18 months or so, 18 to 24 months. Then you look at the hardware platforms, right? Today, there's a various number of players in the ODM space, Acton, DNI, Celestica, Flextronics. And generally, all of these vendors can build a hardware once they have the design for your chips within 6 to 8 months. Right? The next thing you need is your network OS that runs on top of these switches. And if you already have your network OS running, whether it is Sonic or FBOSS or something else, it might take about 9 months or so, and sometimes longer depending on where you are in that software development, to be able to integrate it to the silicon and the hardware that's available. And last but definitely not the least, you've got the optics. And what you see on the optics side today is the development cycle for optics is actually much longer. It takes roughly about 3 years for these optics to be developed. Okay? So in each of these cases, essentially what you're seeing is pieces which are in different development cycles, primarily because one is the physics. Optics, they go through a different cycle than software. And two, the amount of resources, whether it is capital resources or human resources, which are invested in it, right? Now, I want to start to focus the rest of my presentation more focused to the hyperscale and say, okay, first you start with and say, if you want to make disaggregation happen, the first question you have to ask is, what is the network supposed to be in an hyperscale? Because you try to do all things for all people, very, very likely you'll actually be not good at anything, right? And when you look at the hyperscale, the way we think about the hyperscale is it's really a factory. It's a factory of compute, factory of storage. You're trying to get the largest amount of compute and storage as efficiently as possible inside a massive data center. There, the role of the network is very, very simple. I always tell my team, don't come and tell me what new features you want to add. Tell me what features you're going to remove. Because in the data center, the network is a compute fabric. Your job is very simply to take the packet that has been given to you from the NIC or the CPU and send it to the other end. And that's your job. That's exactly what Najam said this morning. I don't want to be anything more than a compute fabric. And I actually borrowed the phrase from James before, which is, get out of the way. Right? You can use a few adjectives in that sentence if you want, but the basic message is get out of the way. Right? So when you start thinking about the hyperscale requirements and say, this is what you need to be able to deliver, which is a compute fabric, and that's all you are, a compute and a storage fabric, then you say, okay, how do you actually make this come to be in a large-scale data center? Obviously, if you look at what Microsoft's done, what Facebook has done, what Google has done, and AWS has done, if they have done an outstanding job in scaling out, right? Instead of using these large boxes and large devices, which traditionally used to be multi-tiered, and you had a lot of oversubscription, you probably had layer 2 running at the top of a rack and layer 2, layer 3 demarcation happening at the aggregation layer, running over subscription at different parts of the network, you figured out a simple way to build your network. One, layer 3. Go layer 3 all the way to the top of rack. If you want to do any esoteric functions, put them on the NIC or put them in the server, right? 2, build very simple clause networks so that you have bisectional bandwidth in your network, right? And 3, essentially, if you think about it, with the number of devices that you have, and once you have this well orchestrated through your orchestration and management systems, it becomes very easy to deploy these. However, the challenge still is, while you've scaled out, are you efficiently able to scale up? And what I mean by scale up here is, you may have just started to get your network running on a device that's 3.2 terabit or 6.4. But then how long does it take you to go from the 6.4 to 12.8? And why does it take you that long, right? That's something to think about. At any one generation, if you actually look at all the different megascales which are there, and from our vantage point, what we find out is not everybody is always, actually, no one particular one is always the first to a particular generation of bandwidth that's available. Somebody might be the first in 3.2. That same company may not be the first to 6.4 terabit, or they may not be the first to 12.8. And that's because while they've scaled out, they still have some challenges being able to scale up to the next generation, and each one has their own challenges. So when you start looking at that, and you say, how do you solve those problems? Now, one, in terms of first to be able to scale up, you have to be able to say first, the silicon is out there. Because if I don't deliver the silicon at whether it is 6.4 terabits, or whether it's at 12.8 terabits, or the next one, 25 terabit, you can't scale up, even if you have the best capabilities internally, right? So as you're scaling up, you'll see basically here 2 things happening. One is the number of lanes, SerDes lanes per device, keeps going up. So there used to be 64 10 gigabit Ethernet lanes per device. Then there were 128 10 gigabit Ethernet lanes per device, or 128, and now 256 25 gig lanes per device. While the lanes have been going up, at the same time, the lane speeds have also been going up from 10 to 25 to 50 to 100, right? So the combination of these have effectively allowed us to continue to scale the bandwidth in a very, very predictable fashion, right? You have to be able to do it in a way that's predictable. You have to be able to do it in a way that is also efficient in terms of cost and area and a power standpoint, right? So as you can see, you can basically plan today, saying, look, today we will have, by the end of this year, 12.8 terabits shipping in production from one vendor, or maybe even more than one vendor. By next year this time, you'll probably see parts at 25 terabit being available in the marketplace. And that allows you as a megascale to start thinking about how do you start to build your network and plan your capacity so that you can grow with the scale up that's available in the silicon. Now, you look at it and say, okay,